Alright folks, going to work through a screening, this time using Stata. So a handout that we're going to be using is our one-way ANOVA screening, but this was going to be the Stata output. Remember that the data set that we're working with in this example, looking at responses to a humorous film across participants of different racial ethnic backgrounds. The question is hypothetically, so we have this stimuli that is supposed to elicit a certain type of emotion, but is this going to be a good stimuli or valid stimuli within an racially ethnically diverse sample. And so what we're going to do is we're going to run a one-way ANOVA looking at ratings of valence, 0 being unpleasant, to 8 being very, very pleasant, and arousal, 0 being not at all emotionally activated, 8 being completely emotionally activated. And so what we want to do is see whether or not we're getting similarities across participants of different backgrounds on this experimental stimuli. So what we're going to do is we're going to start here. We've uploaded the data set. If I go to my data editor and I hit that, here I've got my variables, and I can go through and take a look. Here visually, easy to see that I'm not missing any data here, but I could also go sort ethnicity, and any values that would be missing would be located at the bottom. So that looks good. I can say sort valence. It's looking fine. Sort arousal. That's looking okay there too. There are other commands in Stata that we can use probably to do a more efficient job of seeing if we have any missing values, but this will work for our purposes here. So looks like all of our values are, or we don't have any missing data in this screener. So what we want to do next is we want to go through and take a look and look at our descriptive statistics, and then also make sure that all of our values are falling within range. So remember that for a means-based analysis, a group-based analysis, in our screening, we want to go through and make sure that we're separating groups and looking at the characteristics of our data within each groups individually. Okay, so in Stata, one of the ways we can do this is we can type in by sort ethnicity. Okay, and what this is going to do, you can see here, is it's going to go through and it's going to split and give us output across our different groups. In this case, it's going to be ethnicity. Now, there's a couple different ways we could ask for descriptive statistics. We could use our summarize command. We could say sum, oh whoops, I need to change that, that's wrong, and then the variables that we're interested in, and then hit comma detail. That's going to give our skew, kurtosis, things along those lines. I kind of like the tab stat output a little bit better, so we're going to use that. So I'm going to say by sort ethnicity, tab stat, valence, arousal, and then we're going to ask for statistics. S is short for that, and I'm going to ask for N is going to be my sample, mean ME is going to be my mean, SD is going to be my standard deviation. I could ask for variance. I think it's V, but I'm going to go, we'll just spell that one out. Variance, oh whoops, here, let's go. N, we'll ask for min, max, mean, standard deviation, variance, skew, and kurtosis. Okay, that should give us everything that we are looking for here. So N, min, max, mean, standard deviation, skew, kurtosis. I threw variance in there just to request this, and if I hit that, there we go. And so what I might want to do here is I'm going to open up a do file to keep track of our progress with stuff. Copy that, just say looking at plausibility, and descriptives. Okay, drop that in there. But if we go through and we take a look at our output, so again, remember that we're wanting all of our values for valence and arousal to range between 0 to 8. So we see for our white non-Hispanic group, 0 to okay, that looks good. 41 people. Mean, standard deviation, here's our variance, skew, and our kurtosis values. Okay, now remember that these kurtosis values might look big, but remember that in Stata, no kurtosis is going to be a value of 3. So what we want to do is we want to subtract 3 from each of these. So we say 4.66, 3 is going to be 1.66, so that's not too bad. 2.48, 3 minus that, negative 0.52. So nothing too bad here, at least in terms of anything that we're worried about in terms of our kurtosis. Same thing if we go down to our black non-Hispanic group, 38 people, so similar. All our values are within range here. Mean, standard deviation, variance, and again our skew is looking all right, and kurtosis not looking too bad here. Finally, looking at our other ethnicity group, not a great group as an amalgamation, but again, seeing our values are within range, mean, standard deviations, variance, and once again our skew is looking within reasonable bounds. Kurtosis also looks reasonable. So really here, nothing that we're too concerned about, at least to this point. Okay, so what we want to do though now is we want to go through and take a look graphically and get a sense for our histograms, and we'll request some box plots here. So I'm going to go to graphics. I'm going to go to histogram. Okay, this is going to bring up. I could go. Well, I don't know if I can do that. We won't do that to confuse people. So we'll go histogram, and I want to look at valence, and I'm going to ask for valence by ethnicity. Okay, and what this is going to do is it's going to break my histograms up into different categories. Now we've got a 0 to 8 scale, right? And so these data aren't actually continuous. They're ordered categorical. They're ordinal scales. They're discrete. I know this on the front end, so I'm just going to click this data are discrete. I'm going to choose for my y-axis to reflect the frequency of our outcome. Bar properties, I like to have sort of an outcome there, or sort of these be outlined in black. And then let's go through and take a look and see what this looks like. So I'm going to hit submit. All right, this looks pretty good to me. I mean, if I wanted to get, I could go through and take a look at my y-axis, and then I go to labels, say horizontal, and then resubmit that. It's just going to turn the numbers around. But overall, looks like my histograms across each one of my groups aren't too bad. Here in my white non-Hispanic group, I've got looks like one individual who's set apart from the rest. I would definitely want to take note of that and sort of keep that in mind. But everybody else looking like continuous members of the distribution. So nothing that's looking too concerning, at least on this front. So we can go through, we can hit OK, and it's going to go through. We can take stock of that. I can take my histogram, copy that into so this is going to be documentation of my histogram, but what I can do now is I can just go through and choose that, and I can hit arousal and run that the same way. Okay, and here's going to be histogram for ratings of emotional arousal. Looks like we've got these on a 5 scale. One thing we could do, we won't worry about it. We could change it for it to be 0 to 8, which is our min and our max. But things looking good here. Looks like among our Black non-Hispanic group, a little more spread out. A little bit more spread in terms of our other group, but nothing too crazy in terms of our histograms here. So in your screening, just want to make note of those and sort of provide a description there. Okay, so those are our histograms. No, that's going to open up a new one. Don't save. I'll copy that in. Okay. Then go to, and we're going to request box plots. Okay. For a box plot, going to go to graphic, box plot, and again, request. So we'll start with valence. And then I'm going to go through. I'm going to, instead of hitting by like we did with the histogram, I'm going to go through and I'm going to select categories. I'm going to hit grouping variable is going to be ethnicity here. Okay, and then go ahead and hit submit. That's nice. Okay, that gives us a nice box plot, and we see identical medians in terms of our white non-Hispanic and our black non-Hispanic group, identical interquartile range for both of these groups. Our min and our max, again, our whiskers go to the minimum and maximum value, or the most extreme or the farthest out value that's still within 1.5 times interquartile range. We're seeing our other group is showing higher median reported valence, but same max, sort of more variability in terms of valence in our white non-Hispanic group as compared to our black non-Hispanic and other. But again, just wanting to go through and make a description of what's going on in your box and whisker plots here. So, but things look maybe a little skewed, kind of relatively symmetrical. Your third quartile is closer to your median here. I just want to go through and make some comments about that. So overall, nothing too concerning with our emotional valence. But let's go through and take a look at arousal. Submit there. Okay, so here we've got something a little bit different. We've got what looks to be, again, the same median value across our white non-Hispanic and our black non-Hispanic, slightly higher in our other group. Much more variability, it looks like, in terms of our black non-Hispanic group. Greater variability in our other group. Less variability in our white non-Hispanic group. Here, you'll notice that our median and our third quartile, our median, our 50th percentile, and our 75th percentile are both values of 4. And then we've got 2 cases, or sort of at least values, that are falling beyond 1.5 times the interquartile range, right? So if we take, this is our interquartile range, if we go 1.5 times that above, this is our value that still falls within, our highest value that still falls within 1.5 times the interquartile range. Our lowest value that still falls within 1.5 times the interquartile range, and then our values outside of that falling beyond 1.5 times the interquartile. So for our white non-Hispanic group, we're going to be seeing scores that are going to be looking a little bit higher and a little bit lower. Now if we go through, I can hit shift, copy both of these, and paste those in there. If I want to take a look at my histogram again, so again, remember that it was our, let me see, do I have some of these? No. So for my box plot, it was showing values falling beyond 1.5 times the interquartile range for emotional arousal among white non-Hispanic group. Well, these are looking, so I'm assuming that that's this value and this value, but it looks like that might be more a function of kind of the tight variability of this than anything else. So again, maybe not going to be too concerned about this quite yet. Okay, so that's going to give us our plots. So what we want to do now is we want to go through, if we're following our sheet, we've got taking a look at our univariate distributions within each group. We've taken a look at our histograms, our box plots, right? We're seeing these two values that look like they might be problematic, but maybe they aren't actually. What I want to do now is I want to look at z-scores. Okay. Now remember, I went through and created a z-score file that it was going to go through, and it's going to help streamline calculation of z-scores within each group, because Stata doesn't have a function to do this that's built in. So if you go to the z-score file, right, and so this is going to be separate do file. But what we can do is copy this into your do file. Just say looking at standardized scores, and then drop this down in. And remember that this is just a macro, and our target is going to be our outcome variables. So variance, arousal. Our grouping variable is going to be ethnicity. Our levels is going to be our values for our group. So we've got our white non-Hispanic group is coded 0. Our other is 2. So this is going to be 0 to 2. And then everything else is set. You don't need to worry about that. So we'll go through and run this. And again, what we're doing is we're going to look for extreme z-scores. Okay, so I'm going to run that do file. Uh-oh. Did I spell variance? Oh, whoops, valence, not variance. Valence. There we go. All right. So this is suggesting that it's gone through and it's done what it's supposed to do. If we take a look at our data file, at our data editor, we see our valence and arousal z-scores put together here. So now what I'm going to do is I'm just going to what happened here? There we go. And then I'm going to go through, I'm going to say by sort, which is going to split our file, ethnicity, okay, and then we're going to just go sum or summarize, and then we're going to go z valence, z arousal, okay, and this is going to give us our descriptive statistics by each one of our groups. Okay, so here we've got our descriptives for our z-scores. Again, this is scientific notation for infinitely small values, so we don't need to worry about that. What we're interested in looking at is our minimum and maximum values for our z-scores. So for our white non-Hispanic group, right, we've got a z-score that looks quite low here. Again, we've got a score that's falling about 3 1/4 standard deviations below the mean, right? And so if we go back and we'll just pull it up here, recall that on our histogram we have one value for our white non-Hispanic group in terms of emotional valence that's falling down here, down at the end. So what we want to do that's going to be our score that's corresponding to a z-score of negative 3.26. Is what we'll do is we'll say we want to sort by ethnicity and then by valence. That should do it. Okay. So what this does is it scores first by ethnicity and then by valence. So we can see here our score that's falling far below the mean. Looks like this is case number 68, valence associated with a score of 1, and this is going to be, again, about 3 1/4 standard deviations below the mean. And so anytime we find an extreme value, we want to think about, what does this mean? Well, it looks like we gave people a video that was supposed to be funny and amusing, and this is someone who didn't find it funny or amusing. So we would probably want to note the case number, the score, and then the z-score as an extreme value based on this. But again, if we're taking a look at our distributions, right, we're working on a nominal with an ordered categorical scale or an ordinal scale ranging from 0 to 8. There's only so far out people can be. If I look at this, this is definitely going to be a value that I would note, and note that it's fallen away from the rest of the distribution. It's associated with a small score. I might want to check my my data to make sure that this was a proper entry, but for the most part, it's not going to be something that I'm terribly concerned about there. So go through, make a note on that. In terms of arousal, things are falling within around a couple standard deviations above and below, so we're not too worried about that. For our black non-Hispanic folks, again, minimum, maximum z-scores all falling around 2, so not too concerned there. Same thing with our other group. Again, we've got a smaller score that's starting to creep farther below the distribution. But again, our histograms aren't looking bad in terms of, particularly with the size of the sample that we've got, right? So we're feeling okay given these in terms of violations, or sort of meeting our assumptions of normality of the distribution of sample means. Our box and whisker plots are looking good here. So all in all, a couple things to note, but not anything that we're too concerned about. Probably the biggest issue here is going to be concerns about unequal sample sizes, right? So we've got basically a 2-to-1 ratio of our biggest to our smallest. This isn't huge. It's not terrible. It's not the worst thing. We're going to run into data that's actually much, much worse than this. But again, something to note in our write-up, in addition to a couple of those values that are a little odd. Now, the only other thing that we will need to do when we run our analyses is test for violations of homogeneity of variance. Because we do have unequal samples, we might start to become more concerned about violations of homogeneity of variance, but we'll go through and we'll take a look at that in our actual analyses. So hope this was helpful, and let me know if you have any questions on screening procedures we used here.